In this video, we're going to learn how to qualitatively describe matter. First, let's go over some definition. Composition. It is used to describe the types and the amounts of the simpler substances that make up a sample of matter. What does that really mean? It sounds very complicated. Well, let's look at some example. For example, if we want to talk about table salt, NaCl, sodium chloride, that means we need to have one sodium atom and one chlorine atom. They combine together to form an ionic compound. So the composition of a table salt will be NaCl, and the amount will be 1:1. What about water? Water is H2O. That will be the composition of water. 1 oxygen and 2 hydrogen. And then we can also talk about other gases. For example, carbon dioxide, CO2. So 1 carbon, 2 oxygen. That will be the composition to make 1 carbon dioxide molecule. And of course, we can also talk about oxygen gas, O2. That means 2 oxygen atoms come together, they form a molecule. And you can also have atomic element, for example, Fe, which is iron. So that's kind of composition that we talk about, which atom comes together, and also the number of atoms from that element. Then we start talking about the properties, which is also very important, because once we know the composition, oftentimes the composition is going to give us properties, the characteristic of the matter. And we need to know the characteristics so that we can help identify what substances that we're talking about. So there'll be 2 approaches when we talk about properties. We will look into physical properties and chemical properties. What are the difference between physical properties and chemical properties? Well, for physical property, basically it is, those are the characteristics that we can observe or measure without changing the composition of the substance. Okay, so if you think about a copper metal, you look at a piece of copper metal, you can talk about the color, you can talk about the shape, okay? And the other type of properties is called chemical properties. And those chemical characteristics can only be observed during a chemical reaction. Okay? So think about physical properties without changing composition. Chemical properties, it will be something that will change the composition. So what are some examples of physical properties? Odor, the color, appearance, melting point, boiling point. So when we talk about melting point, it means the temperature that the solid will begins to melt. And if we're talking about boiling point, it is the temperature that a liquid will turn into a gas. And of course, density, that's another physical property. Chemical properties. So I would like to introduce a globally harmonized system of classification of labeling of chemicals. So oftentimes when you work in a chemistry lab, you see all this pictogram. And those pictograms try to tell the people who are going to work with the chemicals, like what kind of safety precaution they need to be aware. Okay, so let's go over a couple of them. I think it's very important for you to know. So for example, the health access symbol is the little human with the lungs right here. That's the health access. So this is the one that if you have a long-term exposure, it will cause damage to your health. So you definitely want to find out, okay, what kind of long-term effects it can have in your health. And then on the other hand, you can also have some chemicals that can be very aggressive or very reactive, so that, a short exposure time, it can be very bad for your health. And that is actually the symbol of the skull with the crossbone. Okay, so that's a short amount of time and it's like a poison. Then another group that I would like you to know, it will be a corrosion symbol. Corrosion is the one that at the bottom with the test tube. So the hands being, like burn or hot, so that is corrosion. And then of course we have some chemicals that are very explosive as well. So again, those are the, when you see those kind of label, you'll be like, oh, I better look at it more carefully. How can I prevent accident from happening? Last but not least, we have a flame over a circle. That means that chemical is an oxidizer. And again, they're pretty dangerous and we need to be very careful. And also we have the flame symbol that's telling you the chemicals can easily ignite it. And there are also other chemical properties such as is this the chemical reactive or not reactive? So when you do experiment, you'll find out. The heat of reaction, something that we'll talk about toward the end of this chapter. Oxidation state. Again, when we talk about physical change, usually we're looking at how the matter changes appearance. But again, without changing the composition. Okay, always remember physical changes, physical property, we are still looking at the same substance, but the composition remain the same. So again, let's use water as an example. Water can appear as ice when the temperature is below 0 degrees Celsius. Temperature can also, water, and then we can have liquid water when the temperature is between 0 degree to 100 degrees Celsius. And finally, we can have steam. Again, it's still water. The composition doesn't change. It's still H2O when the temperature reaches greater than 100 degrees Celsius. Let's go over some of the phase transition that you need to know to describe a physical change. So for example, if we talk about melting, what kind of phase transition are we talking about? We will be talking about solid to liquid transition. That is called melting process. If we're talking about evaporation, that means the physical change, we are changing the matter from liquid state to a gas phase. That will be called evaporation. There is another type that you may have heard about, or maybe it's new to you. It's called sublimation. Sublimation means a substance can go from solid to a gas phase directly without going through the liquid phase. And that means on the opposite spectrum, then we can have freezing. Freezing means from liquid to a solid. We can have condensation. Condensation will be the process from gas to liquid. And finally, the opposite of sublimation is called deposition. It means it will be from gas phase to solid without going through the liquid phase. So those are the 6 different types of phase transition that you will need to know. Then moving to the chemical change, right? So just a quick reminder, when we talk about chemical change, it means that the composition of the substance will change. For example, looking at the image, I'm basically turning on the gas stove. So the natural gas is having a combustion into carbon dioxide and water vapor. Can also look at another very common things that we see from our daily life, rusting process. So if you have a piece of metal, over time it will turn into rust, and that is a chemical change because originally iron is as an element is just Fe, but once the iron is getting oxidized, meaning the rusting process begins, the compound you're forming, the rust, is actually, the chemical symbol is Fe2O3. Okay, at this point, don't worry about the actual chemical symbol, the compound, because that is something that we will learn later in this course. At this point, being able to tell the chemical change is that when you have a composition change. Okay, so from element to a compound, that is a composition change. When you have a combustion, you're burning natural gas, you're burning gasoline, and you turn that into carbon dioxide and water vapor. that is a chemical change. That's a composition change. And what are the other type of chemical change that you may see or observe in a laboratory? Maybe you can mix two solution together, and then all of a sudden you see bubbles are being formed, or you may be adding a piece of metal into an acid, and you start to see bubbles are being formed. So that is a chemical change. You didn't have bubbles at the beginning, but after you start a reaction, you start to see bubbles. That's a chemical change. Sometimes it can change color, or sometimes it can give off light as well, or they may form solids. Okay, it doesn't just have to be bubbles. Sometimes you mix two solutions, you see some cloudy solid being formed right away. So that's another indication that you have a chemical reaction going on, and those are the chemical change. So I have this self-exercise for you to practice, because we just spent quite a bit of time talking about physical property and chemical property. So I want you to go through each statement, and determine whether the statement describing a physical change or chemical change. Once you understand how to distinguish between the two, and you can start studying the statement, try to adopt as you go to the lab, and try to write out some physical characteristic of a substance. So you do have a lab later on, try to write a description of what you see. More self-exercise this time is about, is that like physical properties or chemical properties? Think about whether or not your substance changes its composition. Answers at the bottom. And next one, more statements for you to work on and practice.